Hello everyone. I think the audio is clear, right? So I think we can start with our first problem here. Let's go to description every way of every problem, right? So okay, let's go to the first problem. I think most of the people might be solved with the first problem. Let me tell you, and in the order, if you have any doubts, please let me know in the live chat itself. So let's go with the first problem first. Now, what is given in the problem? Minimum absolute difference between two values. Right? You are given an integer array nums consisting only of three integers, either 0 or 1 or 2. A pair of indices I, comma j is called valid if nums of I is equal to 1 and nums of j is equal to 2. Return the minimum absolute difference between I and j among all valid pairs. If no valid pair exists, return minus 1. The absolute difference between I and j is defined as absolute difference of I minus j. I think you got it, right? So if you have any notes, please let me know. And if you want to share your intuition, please let me know in the live chat. So nums contains 0, 1, and 2. Pair of integers I, comma j is valid if nums of I is equal to 1 and nums of j is equal to 2. Let us see now. Now let me tell you, right? They didn't say that I will be less than j or j will be less than I, right? So the first problem is minimum absolute difference between two values. Minimum absolute difference between two values, right? So first thing uh, we are given with those things nums array, right? And this contains 0, 1, or 2. Now our intuition or our thought process, what we need to return is minimum difference. I'll tell you what difference which we need to take. We need to indices where nums of I will be 1 and nums of j will be 2, right? Should be minimum. That's what we are asked with, right? So nums of I should be 1 and nums of j should be 2. Is there anything? No. So the difference is absolute difference of I comma j or absolute difference of I minus j. Let's take an example and also go with the constants. So they said that the nums length can be till 100 and nums of I can be less than or equal to 2. 0, 1, 2, right? 0, 1, and then 2. Let's take 1, 0, 2, 0, 1. 1, 0, 2, 0, 1. First, let me make this clear. They didn't say I should be less than J and nums of I should be 1, nums of J should be 2. I can also, I'll tell you how I gonna solve this. So I have this one, right, which is at indices. Let me give the indices 0, 1, 2, 3, 4, 5. I have this at index 0, which is 1. Now, after this is not 1 or 2, right? And this is not 1 or 2. Here I got 2. Now, if you see, I'll consider this, which is at 3. So, for now, I had the answer as infinity. I will initialize the answer as infinity, which is the maximum, right? Now, if I see the difference, I am having it as 3, right? Now, let's go again. I have 3 here, I have a 2, and then I have a 1. Now, can I consider this? Of course, we can consider this. So, 5 minus 3 will be lesser, right? 5 minus 3 will be lesser, which is 2. So that's why they are returning 2. This is the only easy problem which have given. The remaining every time they used to give the second problem at least easy, but it's not easy for now. 1010. The next example, 1010, right? So I see a 1 here, but I don't see any 2. So I'll just return minus 1 as our answer is infinity. Now, if you have any notes, please don't hesitate to ask me. So let me write the algorithm first. First, what I did here, I know I have a 1. I know I have a 1. I know I have a 2. I got a 2, right? So if I have, if I need the distance, need the difference, I need to track previous one, previous one, and previous two. Did you hear that? Previous one and also previous two. Why? So here I got a previously a 2, now I got a 1. So that's why I'll always store previous one where in which index I got previous one and in which index I got previous two. Previously where in which index I got one and previously which index I got two. That's what I'm gonna track every time. Now, let's do a dry run here. As I said, I will initialize previous one and also previous two, right? So, initially, I don't know where this previously 1 is there and previously 2 is there before starting at the array. So I'll just initialize both of them to minus 1, right? And I will initialize my answer to infinity or int max as if we go with C++. Now, is there anything which I am missing? Nothing, right? Answer is the difference which I can get. No. For I is equal to 0, I is less than n, I plus plus. I think I should not write the code here itself. Alright, I'll tell you. Now, 100 201. 100 201. Hey, see here 0, 1, 2, 3, 4, 5. Now, as I said, previous 1 is equal to minus 1, previous 2 is equal to minus 1, and answer is infinity. I'll update answer to the minimum every time. Now let us see here. I have a 1. So what I'll do, I'll just change it to the index where I got this one. I'm not saying previous one I got it or not. I'm storing the index where I got the previous one so that I can simply take the difference like I got a 2 here. So the previous one is at 0. So 3 minus the index where I got 2 is 3 and the index where I got 1 is 0. So 3 minus 0 is 3 however. Now, I have minus 1, right? So here I got at 0, I got 1. So previous one is updated to 0. Now, as I got 1, will I check with whether I got it 2 or not? Yes, I will of course check, but it is minus 1, so I don't compute the difference, right? Only if it is not minus 1, if it is already present. What does it mean if it is minus 1? It is not present if it is not even present in the array, right? So let's move forward. 0, no, nothing to do with 0, 0, and nothing to do with 0 again, 2. Okay. When I got 2, I will check with 1. When I got 1, I'll check with 2. That's why I'm storing previous 1, where the index where I got 1 previously, the index where I got 2 previously. Both of them, I'm storing both of them. So when I got 2, I'll check. Do I have a 1 previously? Yes. Where do I have it? 0, right? Now 3 minus 0 is giving me 3, which is lesser than infinity. Now let's move forward, which is 0. But before moving forward, I have 2, right? So previous to I didn't update. So I have to update previous to. Where did I get the previous to? Where did I get to previously? Which is at index 3, right? Now I will go to index 0. Nothing to do with 0. Now I go to 1. Remember, if I get 1, I'll look for previous 2. If I get 2, I look for previous 1. Now I have 1, right? So I will check, do I have 2 previously? If so, which index? So that's why here. 3, right? 5 minus 3 will give me the absolute difference of 2, which is much lesser than 3. So I'll go out of loop and I'll just return 2 as the answer. So what I'm doing exactly? Exactly, I'll just go from I is equal to 0, I is less than n, I plus plus. If, let me write it standing. If I see 1, look, uh, compute difference as I minus previous to. If I see 2, compute difference as I minus previous 1. If I see 2, I'll just check 1. If I see 1, I'll just check 2. Right? Now, there is another thing. And also update. I got 1, right? I need to update previous one. P1. Here also update previous 2. Right? So these two is how I'm gonna write the code now. So answer is equal to minimum of answer, comma, I minus previous 2. And previous 1 is equal to the current index where I am at. And also answer is equal to minimum of answer, comma, I minus previous 1. And previous 2 is the index where I am. Now, there is another thing. If I see 2, I'm just computing difference as I minus P1. But I will do it only if P1 or previous one is not equal to minus. I also need to check compute difference if and only if P1 is not equal to minus 1. Again here to compute difference if and only if previous 2 is not equal to minus 1. Why? Why? Because if it is minus 1, we are saying that it is not present in the array itself, right? So I think it's clear for you. Yes. So if you have any notes, please let me know. Wait, wait. I think you are clear till now. Right? Answer is Intemax. I'm just updating the answer every time. So yes, at the last we'll just return answer. If answer is int max even after running the loop, if it is int max, that means there is no valid difference. So if then I'll just return minus 1. If not, I'll just return answer. Right? That's how you solve the first problem. And I think most of the people who are watching the live, if you haven't solved it, please let me know. So This is the code nums of I is equal to 1, and if nums of I is equal to 2, this will be done. Previous 1, previous 2, and many is equal to max, n is equal to nums dot size. I think it's clear for you, right? We can go to the next problem, which is the second problem. Please let me, please just like this live stream if we can go to the next problem, or if you have any doubts, let me know in the live chat. Yes. So it's just 15 minutes of explanation for the first problem. It's an easy problem actually. Uh, I think if you have any doubts, you can ask me. Yes, I think we can go to the next problem. Right? Direct assignments with exactly k visible people. Right? This one is something like which we need mod inverse. I'll tell you one after the other. Let us understand what is given in the problem first. Let's understand that first. They are saying direction assignments with exactly k visible people. I'll tell you. So we are given with n, position, and k. There are n people standing in a line indexed from 0 to n max. Each person independently chooses a direction, L, visible only to people on their right. So if a person is choosing L, the persons, all those who are, this person who has chosen L is visible to only them who are right to this person. Now, if a person choose R, he is only visible to people who are on his left, right? A person at index position sees others as follows, right? A person I, which is nothing but I, which is lesser than position. A person who is, let me tell you, let me tell you, if this is our position, there will be people here, there will be people here. So I is less than position comes here. I is less than position comes here. I is greater than position comes here. Now is visible. All those persons who are at I is visible if and only if they choose L. If they choose L, they are visible. Now, a person I is greater than position is visible if and only if they choose R. So this R and then R, they are visible. Remaining all are not visible. They are just invisible here. They are just invisible. Only those who are left and choose L, only those who are right and choose R had choose R, they are only visible. I'll tell you how we can solve this. It's just a simple problem. Now, imagine I have position here. How many? So, totally there are n positions, and one is already occupied, and the remaining are n minus 1, right? So, the remaining are n minus 1. These, right? And then these. So n minus 1 are available. From this n minus 1, I'll tell you, return the number of possible direction assignments such that the person at index position sees exactly capable, right? So we need exactly k people where person at position can see, right? So exactly k people, I need exactly k people where person at position can actually see, right? So let us see now. Now I can choose a position here. Let's take k is equal to 5, right? K is equal to 5. For example, k is equal to 5. I can choose a position here, position here, here, and then here. So 1, 2, 3, 4, 5. But what if n is something like 15, right? And from that position is already gone. So 15 minus 1 is 14. From 14, from 14, I need to choose 5 people to be visible, right? I need 5 people to be visible. So it's nothing but from 14, I'm just taking 5 of them. So it's nothing but 14C5. But the problem doesn't end here. Why 14C5 doesn't work? And the answer is actually 2 into 14C5, nothing but 2 into n minus 1. C of n minus 1, comma, k. I'll tell you why I'm multiplying it with 2. Let's take A, B, C, D. This is position. And we are given with k is equal to 2. Now, if I select A, if I select C, let me tell you, let me tell you, from this, from this, can select, A can select either L or R, right? So A can be here or also here. So they can just swap, right? So let me tell you this clear. If A only chooses this and C only chooses this, I'll do. So A is at the left. He is just choosing L, right? Now B and then X. Now C is present there itself and D. And this chosen R and this has chosen L. This is how I place. There is another way where I can place A, C is here, and B, X, D, right? Now there is also another way where A comes here and B, X, D, and then C comes here. Now A comes here and then C comes here and B, X, D comes here. Now there is another way. How many did I get here? How many did I get? 1 into 2, 2 into two, just 4. 4, right? I'll tell you another way how we can place it. So instead of placing A, I can place C here and A here, right? That's also possible. C and then A, C and then A, C and then A. The remaining are just B, X, D, B, X, D, B, X, D, B, X, D. Position doesn't change. The person who is standing at position doesn't change. So we got 4, which is nothing but n minus 1. 5 minus 1, 4. C2. 4 into 3 into 2 into 1. 2 into 1 into 2 into 1, which is nothing but 4 into 3, 12, right? Now, why does it give me 12? Here, I can also place A and then a C and then X. This D can be placed here and then B can be placed here, right? So there are totally 12 into 2, which is nothing but 24 ways I can place these persons such that such that people who are standing to the left are having L and people who are standing to the right are having R. So it is obvious that we will generate. So the answer is obvious that 2 into C, nothing but what do you say this? Combinations, permutations and combinations, right? So there will be n minus 1 CK combinations into 2, right? I already told you why we are taking into 2. Why? Because a person can choose either he can uh, stand to the left or stand to the right. So it's his wish, so his or her wish. So it's just multiplying with 2 would make uh, would make it all possible ways. But the problem is not C n minus 1 comma k 2 into. But the problem comes here C n minus 1 comma k. So nothing but n minus 1 factorial by n minus 1 minus k whole factorial k factorial. Let's take an example 14c5 14 factorial by 14 minus 5 is 9 factorial and 5 factorial. Nothing but ncr is nothing but n factorial by n minus r factorial into r factorial, right? So n factorial by n minus r factorial into r factorial. But we don't do this, do like this. Let's take 5c2. How can I do this? 5 into 4 into 3 into 2 into 1. Now, 5 minus 2 is 3 into 2 into 1. 2 factorial is 2 into 1. Now tell you, what is the thing which I'm gonna just remove? I'll tell you. 2 into 1, 2 into 1, which is minimum, right? So, n minus r comma r. From this, what is the minimum? That's it. I will be calculating in the denominator. So denominator is nothing but minimum of n minus r comma r. That's it. Now I need to calculate. I just had the denominator. I need to calculate the denominator factor. Nothing but 3 factorial. I have 5, but I don't calculate 5 into 4 into 3 into 2 into 1. I'll calculate till denominator, nothing but 3. I'll just calculate 5 into 4 into 3. Why not? Why not? Because I'm just calculating, I'm just removing 2 and 1, 2 gamma 1, 2 into 1. I'm just removing that, the minimum 1. Now, how can I get 5, 4, and 3? I'll tell you how can I calculate numerator for this. For this, I'll start with my numerator, which is 1. So numerator will be numerator into n minus i. And I will start with 0. I will go till minimum of n minus r comma r and I plus 1. I tell you why this works. N minus i. I have n is equal to 5. 5 minus 0 is 5. So num was 1. Now it is 5 into 1 into 5 is 5, right? Now I has become 1, right? 5 minus 1 is 4, right? 5 minus 1 is 4. 5 minus 1 is 4. So 4 into num. 4 into num, which is nothing but 5 into 4. 5 into 4 is 20. Now, I becomes 2 now. I becomes 2, right? If I become 2, 5 minus 2 is 3. Right. So 5 minus 2 is 3. 3 into no, nothing but 20. 3 into 20 is 60. 5 into 4 into 3. 5 fours 23 is 60. Now what about denominator? Denominator is nothing but 3 into denominator is nothing but wait a second. Did I just go minimum of n minus r comma r, which is 2? No, I should not go like that. I need to go n minus I is less than n minus minimum of this, right? Now denominator, I have 1. Denominator, I have, let me just check what I have. Denominator, I am just telling to myself that I have 1. Let us stop here. 3 into 2 into 1 or 1 into 2 into 3. What's the best way? 1 into 2 into 3, right? So I'll just go with denominator is equal to denominator into I plus 1. I will go less than 3 and I'm just multiplying it with 1 into 1. Denominator is equal to 1. 1 into I is equal to 0, then I plus 1 is 1. 1 into 1 is 1, however. I is equal to 1. Then 1 plus 1 will become 2. So 1 into 2 will become 2. Now I is equal to 2. 2 plus 1 will become 3. So 3 into, what is the denominator? 2. So 3 into 2 will become 6. Nothing but 3 into 2 into 1, 6. But the problem is not even here. The problem, the problem comes 60 by 6. Mod modular mod. If I do this, I'll just get the wrong answer. I'll tell you why. So 60 by 60, 60 by 6 is 10. Imagine I did 10 mod 5, right? Then I'll get 0 instead of getting 10. I need 10, but I'm just getting 0, right? So it is just getting out of the information itself. I need mod. Why? Because as they said, return it modulo 1 in 9 plus 7. Mod is nothing but 1 in 9 plus 7. If I just do that, I'll get the wrong answer. That's how. 10 mod 10 modular 5 is giving me 0, but that's what I want to tell you. 10 modular mod will change to some other number instead of giving 10. I think you are clear for now. Instead of giving the number, it just changes the number. 60 by 6. Madhu Vallapu, hi. Hi. Hi, Madhu. How are you? Okay. So 60 by 6 is just 10, but 10 modular mod will give me a wrong answer. So I'm not going to do this. But instead, I will do 60 into inverse mod of 6. I'll tell you what I'm doing here. I'll tell you what I'm doing here. Inverse mod of 6. I'll tell you. I need a number x such that x modular mod will be equal to x. I think you got it. I think you got it, right? So I need a number x such that x modular mod will also be equal to x. How can we do that? How can we achieve that? Let's take a number n. So I need inverse of n, which is x, such that x modular mod also will be equal to n. I'll tell you what I am gonna do here without confusing you much. If I get 5 modular, if I have 1 by n, I need 1 by n. What is the value of 1 by n? 1 by n. Let me tell you. I have numerator, right? I'm just writing numerator by denominator as separately. Numerator into 1 by denominator. Now from 4, I will do mod, right? So that's where the problem is. If I do the modular operation, I'll just get out of the actual value what numerator into numerator by denominator is giving me. So if I just dividing, then I cannot apply modular. That's what the problem is. If I am dividing, I cannot apply modular function. So modular doesn't work when we are dividing. It can work if we are just multiplying. For product, it can work, but for division, it doesn't work. So what I'll need to do? So 1 by denominator, I'll just change it to inverse, right? So nothing but denominator like this, right? But if I just get it, I need the same thing, right? So I need the same thing x, which by doing the modular operation with mod will give me x. Let me know in the comment section how can we do this inverse mod operation. Let's know in the live chat how can we get the inverse mod of a number, right? Let me write it. If we do mod operation while division, we get the wrong output, right? Uh, yes, please let me know in the live chat how can we achieve that inverse mod. Right, I think you got it. How can we give the inverse mod, right? How can we give the inverse mod? Let me tell you, by taking an example. Let's take an example actually why we are not doing it. Let's take a is equal to 10, b is equal to 3, and m is equal to 7, right? If I do 10 mod 7, I'll get 3. If I do 3 mod 7, I'll get 3. Now, if you do 3 by 3, you'll get 1. But actually 10 by 3 is 3.33, which is not even a number. Now the reason which we are doing this is find x such that we are finding an element x by using inverse mod such that b into x is equal to a. Now in modulo we need b into be equal to a mod m. M is nothing but 1 in 9 plus 7. But one thing which we need to do is b into x does not does not have a solution every time. I'll tell you. A is equal to 2, b is equal to 4, m is equal to 6. And just write I wrote down some of these examples. Please let me know if anyone has any doubts. Analytics, yes. So yeah, wait 1 second. Now m is equal to 6. Now 4 into 2 is equal to 2 mod 6, right? Now 4 into 2 is 8 mod 6. 8 mod 6 is 2. Yes, we are right. Now 4 into 1 is equal to 4. Mod 6 is equal to 4. This is not right. This is not right. Now 4 into 2 is equal to 8. Mod 6 is equal to 2. I got it. I got the x value as 2, right? So here it will work. Now let us try a is equal to 3, a is equal to 3, b is equal to 4, and m is equal to 6. Now 4 into x should be equal to 3 mod 6, right? So 4 into x should be equal to 3. Now if I do 4 into 1, 4 into 2, 4 into 3, 4 into 4 will be, let me tell you, it will be equal to 4 into 1 will be equal to 4, 4 into 2 will be equal to 2, 4 into 3 will be equal to 0, 4 into 4 will be equal to 4, will never be equal to 3. So let me tell you how we can solve this. So every time what we are doing is inverse of A is something that makes A into X mod M is equal to 1. Let me take this. Wait. Inverse of A is nothing but a number that makes A into X mod M is equal to 1. Why? Let me tell you why we are doing this. So inverse of A is nothing but, let me tell you this clearly. Imagine I have numerator into 1 by denominator. So 1 by denominator, let us take this as denominator as A. Inverse of A is the number that makes A is nothing but A into X mod M is equal to 1. Nothing but A is nothing but denominator into X mod M will be equal to 1. So that's how we're gonna solve this. And if you have, I know this is somewhat much harder to get it, but if you have any notes, please let me know without any hesitation. Right? So now I'll tell you how we can get this inverse of any element. Now I'm having 1 in 9 plus 7 as mod, and let's take a is equal to 2. So mod is equal to 1 in 9 plus 7 and a is equal to 2. What is the inverse of 2? This is called as Fermat's little theorem, right? So there is much disturbance here. Okay, this theorem is called Fermat's. I think I need to write it clearly. Fermat's little theorem. I'll tell you how. So A is equal to 2 and we are having mod is equal to 1 in 9 plus 7, right? So A inverse is equal to A power m minus 2 mod m. M is nothing but 1 in 9 plus 7, right? So mod inverse of A is nothing but power of A comma mod minus 2. Here mod is nothing but 1 in 9 plus 7. Now, if you clearly see inverse of 2 will be 2 power mod minus 2, which is 5. Let me tell you how many times. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, and then 4. Right? Now, let us check. 2 power mod minus 2. 1 in 9 plus 7. 1 in 9. Uh, okay. 1 in 5. 1 in 9 plus 5. 1 in 9 is nothing but 1, 1, 2. Okay. 2 power, right? Let us just take the power 1 in 9 plus 5. 1, 2, 3, 4, 5, 6, 7, then 5. I think we are good. Yeah. Okay. Let's take 0. Okay. 2 power mod minus 2, right? 1, 2, 3, 4, 5, 6, 7, 8, 5. Okay, the x1 must be in the range of, oh God. So, okay, I think you got it. Able, 2 power 1, 2, 3, 4, 5, 6, 7, 8, and then 5. Where can I get? No, I think we can't get it here. Okay, it's okay. Responsive. You can wait for it to become responsive. Wait, no. So it cannot compute it, but okay. But let's go by this. 2 power mod minus 2 is okay. We got it 5 and then 7 times 0 and then 4. Now, if you see 2 into 5, this one. 1, 2, 3, 4, 5, 6, 7, and then 4. Modular mod will be equal to 1. That's what I want to tell you. So there will be two things which we want to do, power and NCR. That's what I wrote it here. The power function first, it's quite easy. The power function, right? And mod inverse is nothing but power of x comma mod minus 2. Now, I'm just changing it to mod inverse of denominator. Here, let me tell you one thing. Numerator into 1 by denominator modular mod will give me a wrong answer. So I will take I will take mod inverse of denominator where where mod inverse of denominator modular mod mod will give me denominator itself. I think you got it, right? Inverse of 2 is, I think everything is good to go, right? Denominator into x modular mod will be 1, right? I think you are, we are good to go. Where modular inverse of denominator modular mod will be, sorry, that's what I am missing. Modular inverse of denominator modular mod will give me 1 by denominator, 1 by denominator itself. So that I'll just multiply it with num, and doing modular of mod will give me exactly num by denominator itself. So that's how we can solve it. So that's why modular inverse of denominator modular mod 2 into NCR n minus 1 comma k, right? So I think we are clear up to now. If you have any doubts, please let me know in the live chat. Yes. And there is this third problem which is, quite interesting, and also it is quite, uh, will this compute it to power? I think no, it cannot. No, the calculation. No, it cannot calculate that much big things. Right. The fourth problem I'll explain in a separate video, which takes a lot of time. So that's why I'm not explaining it here in this live stream. Right. Let us now go to the third problem, minimum XOR path in a grid. Let me tell you how we can solve this. Minimum XOR path in a grid, you are given a 2D integer array grid of size m by n. You start at top left 0, comma 0, top left cell 0, comma 0, and when want to reach the bottom right cell m minus 1, comma n minus 1. Okay, m minus 1, comma n minus 1, nothing but the bottom right cell. I have 1, comma 2, 3, comma 4. I need the minimum XOR. Let me tell you, you cannot solve this by using the DFS, BFS, or any graph method. I'll tell you how we can solve this clearly and easily. First, let me tell you 1, 2, 3, 4. And I'm also telling you, if you go by those DFS, BFS, and all, you will get much time. Now, what is my intuition is I will create a DP which is having the same thing. 1, 2, 3, and then 4. Here in this DP, I will store whether I get a 0, whether I get a 1, whether I get a 2, whether I get a 3, and so on till 1, 0, 2, 3. That's why, because I'm having, okay, 1000, right? So 1000. So the max dot I can get is 1023. So I'm just storing 0123 till 1023. Now here for every element I will store 1 or 0, right? 1, 0, 0, 0, and then all 0. Why I'm storing all zeros? I'll tell you why. Now I'll tell you why. I can go right I can go down, right? Now I'll tell you why I am storing all are zeros, but the one is only one. Because I'll tell you, dp of I j x is nothing but if one I can get XOR x ending at I comma j. If zero, I cannot get XOR x ending at I comma j. Right? By taking all those stuff, I cannot get that x value ending at I comma j. That's what it is. Now, let's go to. I'll tell you when I am. You see here, this is index 0, 1, 0, 1. I'll go to the left one and I will check. I'll check. Do the XOR here. Here also I will have it as this, which is having 0, 1, 2, 3, and so on till 1, 0, 2, 3. 1 XOR 2. Let me go to the calculator. Excuse me. 1, where is this XOR 2? Will give me 3. So here only 3 will be true, nothing but 1. All others will be zeros. Now, when I am here, I'll go from for eyes all the cells and I'll check the top cell. I'll get the XOR from the top cell and I also get the XOR from the left cell. Now here I'll get the XOR from the top cell. I got 1. Now let me tell you another thing. I not only, it is nothing but I cannot only get XOR 1. I'll tell you by taking a larger example, but understand what I am going to tell you. Here, there might be another elements, another value x where we can get the XOR. I'll tell you when I get to 4, right? Till then, please understand what I am doing here, right? Okay, so, at 3, at this 3, I'm having all this values 0, 1, 2, 3, 4, 5, and so on 1, 0, 2, 3. What I said here, this 4 is nothing but will I will I get 3 as, sorry, 4, right? Get 4 as the XOR value if I end at 0, not 0, right? 1 comma 0 at cell 1 comma 0, 1 comma 0, right? Will I get it? So if so 1, else it will be 0, right? I think you got it. Now let me tell you 1 XOR 3. What will be 1 XOR? Oh God, 1 minute. 1 XOR 3 will be 2. Okay, I got it. Will be 2. So only 2 will be 1, remaining all will be zeros, right? Now I will go to 4. Here comes the actual thing. I can get the XOR from the top and I can also get the XOR from the left. So if I get the XOR from the top, only 3, I can get only 3 as the XOR. So 3 XOR 4, what will be the value? What will be the value for 3 XOR 4? 3 XOR 4 will be 7. So 7 will be 2, 0, 1, 2, 3, 4, 5, 6, 7. and so on, 1, 0, 2, 3, 7 will be true. Now I can also get from here 3, right? So at 3, I got only XOR as 2, right? So 2 XOR 4. Ending at this cell, I got only 2 as the XOR value. So 2 XOR 4, what will be 2 XOR 4? 2 XOR 4 will be 6. So 6 also is true. Remaining all are 0. Now what I'll do is nothing but I'll go for dp of m minus 1, m minus 1, all x, right? Uh, x for auto, x in dp of m minus 1, n minus 1. If x is true, then we'll just return x, right? I think we got it. Now, here I'm saying that I will not look at the element. I will look at the XORs which I get at that cell. I will look, I will look, I'll just write, I will not look at the top left element and uh, top element, top element and left element. Instead, I will look at x values at top cell and x values at left cell, which which are true. That means if if you have understood only this thing, that dp of I j x is equal to 0, nothing but if it is 1, it is clearly saying that I can get x value as XOR ending at cell I j. If you got it, this simple thing, then you can solve this problem. I think you got it, and I have given the code link. I didn't give in the description, but I'll give when this live ends. But this is how we solve it. I'm just going from for I is equal to 0, I is less than m, I is I plus plus. So I just went like this, right? So that's what I did. Just went every row column wise. For I is equal to 0, row, and then for j is equal to 0, j is less than n, every column, every row, every element. I is equal to 0 and j is equal to 0, then continue. Why? Because dp of 0, 0, grid of 0, 0. Nothing but here, as I said, as it is having 1, I am saying that I can achieve XOR 1 at grid 0, 0. Right? So that's why dp of 0, 0, grid 0, the first, the top left element can be achievable. That's what it means. Now, if I is equal to 0 and j is equal to 0, continue. Right? So the top left element is already there. So continue. We don't need to do anything there. If I is greater than 0, now I is greater than 0. Nothing but I'm at this below rows. I is greater than 0. X is equal to 0. X is less than max. Now again, max is 1024, less than 1024 will go till 1023. If dp of I minus 1 jx, I minus 1 jx, j I minus 1 j is nothing but the top element. I'm just checking the top element. What are all the XOR values which I can get at the top element? That if it is true, then current is nothing but I'm just taking a bit set which is having 1023 elements, nothing but a vector kind of thing, right? So current X XOR X is nothing but the previous the top cell which is having the XOR X, right? Which can be achieved X XOR grid IJ, the current grid will have something, right? So that's I am making it as 1. Now if j is greater than 0, then I need to look at the left element. So x can be x is equal to 0, x is less than max, x plus plus. dp of I, j minus 1 is nothing but the previous element, the left element. X is nothing but the element which is having the XOR x, where I can get the value x. Now current X XOR grid ij. If I do XOR with the previous element where I get all those XORs, if I do with the current element, then I'll get that value. That value will be made as 1. That XOR value. If you see 1, 3, and 5 are the previous XOR values which I can get at the left side. Now what I'll do, I have an element 2 here. So I'll do 1 XOR 2, 3 XOR 2, and then 7 XOR 2. 1 XOR, let me do 1 XOR 2. I'll make 3 as true. Then 3 XOR 2. I'll make 1 as true. Then 7 XOR 2. I'll make 5 as true. Right? So if you have any doubts, please let me know in the live chat because it is not a simple problem. It is definitely a problem which needs a 3D DP. Right? So we are using a 3D DP here. Now dp of ij is current, nothing but we are just making a vector here. You can also use vector of int. It's your wish. Now dp of ij, I'm just changing it to the thing. All those or values where I have made 1, I'm just making it to the cell I comma j. Now x is equal to 0, x is less than max, x plus plus, dp of m minus 1, n minus 1, x. If it is true, then we'll just return x. And if it is, there is no element which is having the XOR itself, right? The last element didn't even have it, even one XOR value, then we'll just return minus 1. So that's how you solve this problem. I'll give the code link in the description. But before going out of this live session, please make sure you understand all the three problems. If you didn't understand even a small thing, a small topic, or even a small thing which you didn't understand, please let me know. Right. So we'll be ending this at 11 p.m. exactly. We have 6 minutes. If you ask me any doubt, even if it takes 1 hour, I'll be there and explaining. So, so we'll be ending this live stream in 6 minutes exactly at 11 p.m. So please let me know if you have any doubts. Wait a second. No, it is audible in my mobile. Fly high. Please check your speaker, right? Is it mute for everyone? Please let me know. I didn't change anything, right? So if it is one, please let me know in the live chat. Please let me know if it is mute for everyone or only one is facing the problem. Yes, please let me know if you have any doubts. Thanks for commenting, Fly High. Uh, I don't know your name. So we are ending this live stream. Thanks for everyone who attending this lesson. Thank you.